Having engaged with the opening scenario, interacted with the puzzle plot text, and analyzed the data set, the final task in each data puzzle lesson is for students to put the pieces together to construct a final explanatory model for the investigative question.
So in the data puzzle as written, the final portion of the lesson is to go ahead and create a model incorporating all of the ideas and the things that the kids have learned. So at this point, the kids have a good understanding of the relationships that exist between all the different organisms. And now they understand that certain organisms rely more on one type of algae over the other. And they've made some predictions about how sea ice melting might impact populations of those particular types of algae, and then as a result affect populations of organisms that eat those algae, or organisms that eat the things that eat the algae. And I give them like an 11 by 17 piece of paper, and it has the ocean and the air and the sun and like a little piece of ice on it. And then they cut out all the different organisms that we're focusing on in the expedition, and then they just glue them on and make connections. They, as a class, create a gotta have it checklist of all the things they think that they need to incorporate in their model. So they come up with things like, we need to incorporate the data from the data puzzle, so the fat data, we need to incorporate primary productivity rates, we need to incorporate feeding relationships, and then they, in small groups, create a final model. We do some model, like a model gallery walk, where the kids go around and look at everybody else's model and provide feedback and notice similarities and differences, and then have a little bit of time to go back and make revisions on their own models. And then at that point, we end the learning expedition with an individual kind of summative assessment task, where they basically tell the story of what is happening in the Arctic as the Arctic sea ice is melting. And just the difference between the initial predictions and the final model is always pretty stunning. But it's a great way for me, first of all, to really see kind of their growth and the connections that they've made with all the different activities that they've engaged in. But it's also this wonderful opportunity for them to see their own growth. And so it's a really nice kind of just self-reflection for them to see, like on paper, like how much their thinking has grown.
In this video, middle school science teacher Erin Mayer describes how she supports her students to reflect on all that they've learned and to represent these new understandings in a final explanatory model. Note that Erin used the Tracing Carbon Through the Arctic Ecosystem data puzzle as part of a larger unit, or learning expedition as she calls it.